Hi everyone, week 7 architecture operating system, the second video and lecture for this week. In the last two videos and worksheets, I tried to explain you the rules and laws for Boolean algebra to be able to simplify the circuits. In this short video, I'm going to solve two problems and tell you the steps that how we can use all of these rules and laws to simplify the circuits. Uh, all of the formulas are this sheet that it's available on the Moodle. You can use them, and I'm going to tell you and show you how we can use them. But a couple of things before we start. I think a good approach is to, and a step by step approach is to first of all try to get rid of the brackets. If you can get rid of the brackets, you can use most of these rules. The other one is to don't forget that De Morgan rule De Morgan rules are quite good. So whenever you can use De Morgan rules, use that. And also, what is important that in all of these rules and laws, you can substitute the variables and you can put two of them, for example, together. For example, in rule 10, what we have is a plus ab is equal a. Look, guys, I can replace that by cd. So CD plus CDB is equal with CD. As you can see, we can actually change these rules by using different names and inputs. But let's see how we can solve problems. So the first one is the circuit that I'm going to show you and tell you how to simplify that. So this is my first circuit that I want to simplify using Boolean algebra. So what I do, first of all, I try to translate it to a Boolean expression. What I see X as an output, it's an OR gate here. I start from right to left. And I see three inputs for that. So I have three inputs, 1, 2, 3. So this is 1, this is 2, and this is 3. 1, 2, 3. So what are each? 1 is an AND gate between A and B. A, B. 2 is an AND gate. One side of that, one input is A, and the other one is an OR gate between B and C. B or C. And last one, the third one, again, it's B and C, B or C. It's an AND gate with B. So in this way, I could translate this circuit to Boolean expression. Now I've got to use all of these rules to simplify that. How to do this? X equal AB plus AB plus C plus B plus C. I told you the first step is to remove the brackets. How? There you go, using distributive rule. So I use distributive rule here. Distributive rule. I use distributive rule here to get rid of these brackets. How? By multiplying them. What I get? X equal AB plus AB plus AC plus BB plus BC. Look, guys, in rule 6, we see that there is no need to repeat. BB is B, AA is A. So here, rule 6. Not only that, in rule 5, there is no need to repeat. A plus A is the same as A. So I've got AB and AB. I can use rule 5 here. It means that no need to repeat. Give some more space. X equal AB plus AC plus B plus BC. So what I see here, guys, I can take a common factor of B. This is one way to do that. But if you look at rule number 10, which is very important rule, A plus AB is equal with A. This is exactly similar to that, but change A to B, change B to C. You will see that we get the same thing. So rule 10 tells us that B plus BC is what? Is B. I write with another color. It's B plus AC plus AB. But what if I forget this rule? No worries. Look, guys, if you forgot that rule, but actually you will be provided with the formula sheet. But what I see is that there is a common factor of B there. So I can use distributive rule again, but in that case, try to take a common factor. And I see that B, if you take a common factor of B, from B, 1 remains. This one, C remains. I get B plus 1 or C, B and 1 or C. This is 1 or C, 1 or C, rule number 2. It says that it's equal with 1. Do I need to memorize that? No, because that's an OR gate. When one input is 1, definitely the output is 1. So this is 1. And what I get is B and 1, which is equal with, what rule is it? Rule number 4, which is equal with B. Same story. It's equal with what I get. AB plus B plus AC. Again, what I have here is rule number 10, same structure. This is rule number 10 again. Rule number 10 tells us that AB plus B, similar to this, look, the same structure that I have, is equal with B. B plus AC. So this is the simplified version of our circuit. That was the circuit that we had. As you see, we had 5 gates there, but by using all of these simplifying rules, what I got is A and C, or B. So as you see, we converted and we changed this circuit, which is complicated one with 5 inputs, with 5 gates and loads of operations there, to the very simple one which we have here. That was the first example I wanted to solve. The other one is, which is a bit more complicated, that we want to go through that, is here. This is my second example. So, how to solve this? To solve this one, again, I've got to, in the first step, I need to actually write the Boolean expression for that. How to do that? So, if you want to write, again, you've got to start from here. It's an AND gate. It's an AND gate. So one leg of this AND gate is C, as you see. C AND. Inside, the whole thing is for the other one. So I've got one OR gate here. Look, this is my OR gate. I know that I've got one OR gate. So OR gate, one leg of this is this gate, which is what? This is B naught. What is this? This is A naught. A naught, B naught, or B naught, A naught. Let me write it as A, B naught. A naught, B naught. No difference, but just to actually make it better. The other one, the other leg is this side, which is an AND gate. Again, I've got an AND gate. Look, this is the AND gate for that. One side of that is this. One side of that is this one. One side is what? B naught and A. A, B naught. And what about the other one? Sorry. The other one, we've got an OR gate. There you go. This is my OR gate. One side of that is B and D. B and D. One side of that is C. So this is how I translated the circuit to this one. C equal A, B naught. C plus B, D plus A naught B. So what I told you was that, guys, first of all, remove the bracket using distributive rule, because in distributive rule, we can multiply and remove the bracket. So what I do, distributive rule, and what I do, multiply that. What I get is C, A, B naught, C, plus A, B naught, B, D, plus A naught, B naught. So, first of all, B naught B. Look, guys, here, rule number 8. Rule 8. B naught B or B not B, because one of them is 1, the other one is always 0. This is an AND gate. What we get, it's 0. It means that the whole thing would be 0. Why? Because this is 0, 0 in an AND gate, because we've got 3 inputs, but one of them is 0. Definitely we get 0. So it's become equal with A, B naught C plus A naught, B naught. Again, distributive rule. I use distributive rule again. Distributive rule, what tells us? Multiply A, B naught C plus A naught, B naught C. So that's perfect. What I see here, that I've got a common factor of B naught, C naught. I use distributive rule again, but try to take a common factor. Why? Because I can see A and A naught here. Look what I get. If you take a common factor of B naught C, I get A from the first one, from the second one, or A naught. These are the remainder of the other terms. So what I get? B naught C and A or not A. There you go. What is this rule? Rule number 7. Also, do I need to know the rule? No. A or A naught, always one of them is 1. So the output is 1 because it's an OR gate. So this is equal with 1. So it's equal with B naught C and 1, which is equal with B naught C. So this is the final answer for this. It means that that very complicated circuit, it's equal with what? It's equal with B naught C, as I showed you. It's the same as B naught C. What is B naught C? Do I need A? No, only B. I've got to invert that. Then it goes to an AND gate with what? With C. These two circuits are the same. But the only thing that I did, I used actually all of these rules and laws here. For this subject simplification, what you need to do, you need to practice, practice, practice. There are lots of questions and exercises on the Moodle. Please watch this video, try to solve these problems again, and do all the exercises. We've got loads of drop-ins and practical sessions that we solve more. I will provide you with more examples later on. Thank you very much, guys.